Hi guys, welcome to PyHacks. So today we're going to take our first delve into object-oriented Python. We're going to start with looking at classes and class methods. So let's give you a little run through of what classes are. So in this tutorial we're going to essentially create a mini game. This mini game is going to be called a Transformers game. So we're going to have a base class of Transformer, and then we're going to create Transformers on that. And we're going to allow the game to add damage to that transformer, the transformer to then get health back and restore his energy. We're going to create Optimus Prime initially. So look at the diagram on the right. You can see that they've got this car class. It shows a initial car, so that'll be our initial transformer. And then the car can have different flavors. It can have different colors, as the first set of properties show. It can have different makes, as the second set of properties or attributes show. And they can have different models as well, so a Mustang, Prius, or a Golf. So these are properties of a car. And then other things around methods would be the type of, the number of gears that the car's got as another method. But then what you can do with the steering wheel, can you turn left, can you turn right? All cars will have that property in them. So that's when we're going to inherit these base methods from our superclass here. So this is our superclass. These are our base classes or our child classes, however you want to refer to it. So let's get going in coding up this cool Transformers game. I'm really looking forward to this example. So without further ado, we're going to get started. So when we create a class, we've got to use the keyword class. And the class serves very much like a blueprint. So anything you want to create, so if I wanted to create a car, I'd have certain properties around the color, the size, how many number of doors, the make, the model. The make normally, but I'd have that as a property. And then I'd have things around the class methods. So what that car can do, can it drive? How can it steer? Can it accelerate? Can the engine rev? They're things that do things as opposed to properties that describe the class. And that's the difference between attributes, properties of that class, and methods. So we're going to create our class of transformer. So class transformer. And we're going to then exit out. So what then we do is we create a initialization statement or an init function. You might have heard the term constructor. This is where we create some attributes of our class. So in Python, when you want to reference the class itself, you use the self keyword. So the self keyword just says refer back to the base class, basically. So what we're then going to do, so it's essentially, represents the instance of that class to access the attributes and the methods of the class. So we're going to basically want to access those attributes and methods, and we can do that by using self. As I've described earlier, attributes and methods are either properties about the class or methods are things that do things within that class. So the print function is an example of a method. It prints something out to the console. For a transformer, it will be adding damage, taking damage, printing out the current damage level. And that's what we're going to explore now. So just remember that every class needs this self statement. And then we're going to add properties. So I'm going to pass in the name, special move, and damage to that class as parameters. So when we construct that class, it'll expect those parameters to be added. So these are going to be called our construct objects when we construct that class. So here to access these attributes, we use self. Can you see that my IntelliSense has shown me what to do? Dot, and then it says we've got a name variable in there. And it actually does auto completion for us. So I could just tab autocomplete here. So what it's saying is when this name's passed through, when we instantiate this class, when we create an instance of this class, the name of the class is going to be set to the name that you put in there. The same of special move. The same of damage. And we're also going to create something that we've not passed, which is going to be like an audit log, a tracking variable, which is going to be a list item. We're initializing an empty list. So these two square brackets here. So we've done an initialization statement. What we're going to add now are class methods. These are the things that actually perform actions within that class. So we're going to create a damage. Oh, I've got to get my def. Damage added. Reference self, and we're going to have a variable parameter damage taken. I'm going to say if our damage taken, so the thing that's passed in here, is equal greater than 0. So if damage has actually been taken, self.damage, so the original damage that's passed in. So if I add in a 1 damage, it's going to keep adding to that. So to do that, to append it on, plus and equals. So the initial variable, keep adding to it, keep track of that. I'm going to cast it to make sure it's an int, an integer, to damage taken. So from there, we're then going to say, we want to then append to our list. So we're going to append the damage taken. So you can see that the damage taken is inherently linked to the damage. So it's always going to update this damage. What we're going to do as well at the top here, we're going to create another definition, another method. I'm going to call this damage level. This is going to take no inputs whatsoever, but it will need a self statement in there. Every method you define needs to have a self, because it needs to be able to reference this outside a superclass here. So I'm going to say if self.damage is equal to 100, so we'd expect the transformer to be defeated if the damage is up to max. The transformer has been defeated. Else print the current damage level is, and we're going to format this because we're going to pass in self.damage. It's like an update, so every time it gets called this method here, it's going to then print out one of these two, but dependent on the tracked damage. Okay, I'm also going to want to do this perhaps every time damage is added. So I'm going to put a call in here to the actual self, because I want to reference an object in that class, damage level, and that appears now, look, as you can see here, not damage added, damage level. And I just use the curly braces because it is a method, but we're not passing anything through to that method. Okay. So we've got our damage level, we've got our damage added function method. We're going to have a damage reduced method now. Got to get my indentation right, it seems to be going all over the place. So make sure that's right. You can see def. I'm going to say then damaged reduced, and I think I'm getting an error because it's not finding the indentation right. Damage taken, and this is going to be the opposite. This is going to deduct damage. So we've actually, say your transformer's navigating through the environment, and it's then picked up an energy block to then revitalize his health. So one of those little health packs. It's then going to take off from the damage. So we're going to say if damage taken greater than 0, self.damage, so update the damage variable, but actually this time do it negatively, so take away integer damage taken. So here we had add, here we've got deduct. And then we're going to call the self damage level again to get a printout, an update of the current level of the damage of that transformer. Self.damage track append damage taken. So now we've got this damage reduced variable. So then we want to add one more method to our class, and then we're going to actually play the game and call some of these methods that we've just created and instantiate the class and work with it. So def, I'm going to say gets damage list. So this is essentially going to pull back this damage track here. So we're going to say for our list item in self.the damage track list that we created at the start, I'm going to say if the list item is less than 0, print health restored to transformer value. The current value is. I'm going to format that. Okay, I'm going to pass in self.name and the list item that we're working with. So list item doesn't need to be self because list item is present in this class definition here, in this method definition. But self refers back to the original self.name, self.damage that's going to be passed through to it, and name. No, self.name that's originally passed. So if I call him Optimus, then it's going to look for that parameter that we passed through when we instantiate the class, and it's going to return that back. I'm going to put an else wrapper on this after we've learned about conditional statements in one of the previous tutorials. Again, please reference that if you've not looked at the previous tutorials. Print damage added to transformer value. Dot format self name list item. Okay, so that's our class ready to go. So we're going to save this. We're going to run all these lines and make sure everything's okay. I'm not getting any syntax errors, so hopefully all good. Okay, let's delete that. Let's run this. So we've got a class called transformer, but we've not instantiated the class yet. So what we need to do now is when you're creating classes, most of the time you're going to run this as a separate program. So I'll show you how to split out the classes later on. So you have to import the classes like you do with NumPy and Pandas, Matplotlib, etc. So I'll take you through how you split classes out later on. But for now, we're going to create our transformer game. We're going to say if the name of the script is equal to main. So this is a command. So most of the scripts that you'll pass in Python, you've normally got a main.py. So you need to specify this so it can actually work with the class in one line. So we're going to instantiate the transformer, and I'm going to call him Bumblebee, my son's favorite transformer. Equals transformer. So you can see that it's got this class now that it's found because we've created it above. I'm going to we've got some parameters now to pass to that class. So can you remember here how we set the self.name equal to the name that's passed? So it sets the class parameter name equal to the name that's passed, and so on. So I'm going to call him Bumblebee. I'm going to set his special move to, I know this a lot because I watch a lot of Transformers with my son, Sting Shot. I'm going to initialize the damage as 0. So at this stage, Bumblebee's perfectly healthy, he's taken no damage whatsoever. So if I run this here, you'll see now that in my environment, I've got a class that's been instantiated from the Bumblebee, and the class is of type Transformer. Yeah, so it is a Transformer because we've created this class. And within that class, there's all these attributes. So we've got special move, name, get damage list, damage track, all these things that we've created prior. Damage added as you can you see what it says here? Method, level, method, reduced, method, damage track is a list, because it's a list item that we're keeping track of, and get damage list is a method. And then all these here are actually properties, but we've not instantiated them or initialized them as properties yet. We're going to do that in another tutorial. For now, they're just parameters that we're going to pass through to our class when we initialize it. Okay, so we've set up Bumblebee. Now let's do stuff with Bumblebee. Let's play the game. I mean, obviously you'd have probably a fancier front end than this. So we're going to add some damage to Bumblebee. We're going to say that he's been blasted by Megatron or something. He's got 40 damage. So I'm going to call that and run this. So current damage is, we probably needed to put space somewhere. Here, I think. Yeah, so we've got 40. And then I'm going to add another 20 damage to Bumblebee. So Bumblebee, we're going to add some more damage to him. This time we're going to add 10. So if I run this, you see that actually, because we've added this statement here, it's going to keep incrementing onto the damage. Say then Bumblebee gets his health bonus. Say he picks up a health pack. Health pack picked up. Bumblebee. Damage reduced. Say we're going to reduce it by 30. I'm going to run those lines again. Now he's reduced it by 30, so we had 50 before. 50 take away 30 is 20. And then we can add some more damage. Just keep going. So from 20, I'm going to add 80 on to make it 100%. So now the Decepticons struck its final blow. Add damage to defeat. Bumblebee. Damage added. So how much did we say? 80, didn't we? So let's run this again. See what happens. So you can see now that we put this check in, didn't we, before? So we've got this get damage list item, so that'll print out every time damage is taken. But here, and this one as well, so we need to perhaps put a space in here, so it prints out better. But once the damage is passed as equal to 100, it's going to say our transform has been defeated. So it's essentially game over at this stage. So Bumblebee's been defeated. But this relies a lot on us passing in parameters. The next part of the game will start to introduce some more random components, and we'll cover the concept of inheritance. So in the next stage, we're going to then separate our transformer class out. We're going to call our transformer class Autobot and the other one called Decepticon. And then from that Decepticon class, we're going to create different species of Decepticons. So because I, again, watch a lot of Transformers with my son, he loves it, we're going to create Predacons and something called Seekers. But to really emphasize that inheritance is really important, and it does save you having to, if you didn't have inheritance, you'd have to type this out every time you wanted to create a new class object. So we'd have to add all the methods again, all the properties that we're going to create, it'd have to be done for every specific object or class that you create. With inheritance, what I can do is say, I'm going to use this transformer as my blueprint, but then I'm going to add some more funky stuff to it. Or I'm going to use my Decepticon as a blueprint and add some more funky stuff. Therefore, if I had this code, 54, and I wanted to create a couple of different types of and variances of Transformer Decepticon, it could end up being thousands of lines of code. But if I inherit, I can probably take it down to 100 to 200. So that's the real power of classes. They give you that template that you can then build other transformers on top of, or other objects on top of. So finally, we're going to do Bumblebee, get damage list. So that will just print out the damage list. So you can see that now it's been keeping track of these values that have happened. So 40, then we pass the value of 10, then 30 and 80. It'd be good to track the cumulative value as well, which we potentially could amp up the class there. If I wanted to create another transformer, it's very simple. I'll call this one Optimus. So Optimus Prime. Transformer. Optimus Prime. Let's say his special move is an Axe Blast or an Axe Blast will do. And he starts with 0. And then we can then initialize Optimus the same way as we did with Bumblebee. So Optimus damage added. We're going to take damage of 50 straight away. Speaking of my son, try to put emails off while I'm doing tutorials. He's got a swimming lesson. Optimus dot damage added. So we instantiated another, and Optimus is going to do really badly. He doesn't actually restore his health at all. He's just going to get defeated straight away. Get a damage list. So we know that that's what's going to happen here. You can end up having two objects in our variable explorer, one called Bumblebee and one called Optimus. Damage has been added to Optimus Prime. His value is 50. Added again, 50. And then if we kept going on it, it'd be defeated at that stage. So that's how you create a class. We did that relatively quickly. Created the class, did a constructor on the class, created class methods, as we saw before when we dropped this down. These are all class methods. And then we started to play our Transformers game as well. In the next set of tutorials, I'll cover inheritance and the importance of inheritance. I hope you've enjoyed that tutorial. I really enjoyed playing the Transformers game with you. Like I say, if you really enjoy that, leave me a comment. If there's anything we can teach you better or any areas that you didn't quite understand, get in touch with me as well. Subscribe to my YouTube feed. Please grab the source code from GitHub and play with the game yourself. And I'd be happy to help you adapt that game in any which way you want. But yeah, it's been great. You guys take care, stay safe, and I'll see you again.